So example is aldehyde is acetaldehyde, or we know according to IUPAC it is called ethanol. We have two carbon atoms, so it is ethanol. It undergo hydrogenation, that is reduction by hydrogen in presence of nickel catalyst. The product is CH3, CH2, OH. It is 1 degree alcohol or it is ethanol. And if you are using ketone, example CH3, CH2, C double bond O, CH3. Total number of carbon atoms are 4, so it is butanol. No need to write butan 2ONA because you don't have butan 3ONA. So simply you can write butanol 1, 2, 3, 4. Total 4 carbon. Butane is replaced by ONA. So it is butanol. It undergo hydrogenation in presence of, usually you are using nickel catalyst, or you can also use platinum palladium also as the catalyst. The product is CH3, CH2, then it is CHOH, CH3. It's a 2 degree alcohol. Here it's a 1 degree because OH attached to CH2. Here it's a 2 degree alcohol. And name of this compound is, it is butan 2O. You have to specify on which carbon the OH group we have. It is on the second carbon, so it is butan 2O. Well, can you use LiAlH4 for these two reactions? The question arises, why cannot use LiAlH4, that's lithium aluminum hydride, for these two reactions? Well, we can use, because it's a powerful reducing agent. When you can use LiAlH4 for the conversion of aldehydes and ketones into alcohols. But we cannot use nickel, palladium or platinum as a catalyst, as a hydrogenating agent for the conversion of carboxylic acid into alcohol. We are using only powerful this reducing agent like LiAlH4. Example for the conversion of carboxylic acid into alcohol is, I am writing simple example, CH3, CH2, C double bond OH. As we know, this is called with it propanoic acid. You can write any other acid also, this like acetic acid, etc. Propanoic acid undergo reduction by powerful reducing agent like LiAlH4. The product is CH3, CH2, CH2, OH. Here C double bond O convert into CH2. Well, this is the second method we are using to prepare 1 degree or 2 degree alcohols. Well, the next method is important. It's from Grignard reagent. In first topic, in the first organic topic, you are studied what is meant by Grignard reagent. Alkyl or aryl or alkyl magnesium halide, or it is RMgX, are called Grignard reagent. And we have synthetic application of Grignard reagent. We can prepare any type of organic compound by using Grignard reagent. Here also we can get 1 degree, 2 degree and 3 degree, that is primary, secondary and tertiary alcohol from Grignard reagent. Well, third method is from Grignard reagent, that is from RMgX, from Grignard reagent. Grignard reagent, or it is RMgX. RMgX. This is the third method or the preparation of alcohol. All types of alcohol can be obtained from this. Well, primary alcohol is obtained by using formaldehyde. It's very important. Only formaldehyde, when interact with the Grignard reagent, primary alcohol is formed. Aldehyde other than formaldehyde gives the secondary alcohol, and ketone gives the tertiary alcohol. So from the Grignard reagent we can prepare 1 degree, 2 degree and 3 degree alcohol. So it is A 1 degree alcohol is obtained or is prepared from formaldehyde. We know the formula for formaldehyde. HC=OH. This is the formula of formaldehyde. We know the formula for Grignard reagent, RMgX. RMgX. It's the formula for Grignard reagent. And again, the carbon is attached to the electronegative oxygen atom. So, pair of electron or pi electron move to the oxygen. It becomes negative. And here we have electropositive magnesium and electronegative X. So, this is more electropositive compared to the alkyl group, Mg. So, we have delta minus, and this one is delta plus. Electron move to this one, remember it's very important, and this is the simple method we are using to prepare alcohol, 1 degree alcohol. So, R get interact with this carbon. This is because it is more positively charged due to the movement of electron on the electronegative oxygen atom. It's more positively charged. Negatively charged R attack on this, and you are getting this product. It's HC. Then we have R. It's OMgX, and afterwards addition takes place. Afterwards, this one hydrolysis, usually in presence of acid, you are getting the product. It's RCHHOH and MgXOH. So we are getting 1 degree alcohol. I think you have followed how the reaction taking place. R links to this carbon because it becomes positive now. Negative part links to this one. Mgx to this oxygen, it's a positive, so it linked to the negative part, and you are getting this product. It's a HCOMgX, R and H. I am rearranging this one. I am bringing the R on this side. So it's a R CH2, this H here. Then it's a OH, OMgX, OH, and MgX becomes a OHC. I am writing H2O like H plus and OH minus. So OH minus links to this one, H links to this one, MgX interact with the OH to give this product, 1 degree alcohol. Example is formaldehyde H, C=OH, and I am writing CH3MgR. We know name of this compound is alkyl magnesium halide. It's a methyl magnesium iodide. Methyl magnesium iodide. electron move on this oxygen, it become partially positively charged, so it links to this one, and the product is it's H, then it is C, OMGI, and afterwards H and R. I mean it's a CH3. Then it undergo hydrolysis by H2O in presence of acid gives the CH3, this is CH3, CH2, OH, then MgI and OH. This is called ethanol or 1 degree alcohol. OH attached to the CH2 or primary carbon. Second, B is 1 degree alcohol. 2 degree alcohol is prepared. Alcohol is prepared from aldehyde other than formaldehyde. So 2 degree or secondary alcohols obtained from the aldehyde other than formaldehyde. Formula for aldehyde is R, C double bond O, then it is H. It's a formula for aldehyde. Plus Grignard reagent. I am writing R dash instead of writing R dash MgX. Product is, as we know, electron move on this oxygen, it's partially positively charged, so it move to this carbon, and the product is, it's R, then it is C, R dash, start at so in preparation of alcohols, we have studied different methods. One is from alkenes, then from carbonyl compounds, and then by using Grignard reagent. So from alkenes we have 2 methods. One is acid hydration of alkenes. So here hydration means addition of water. We know water has 2 parts, one is H plus and OH minus. Alkene means which contains a double bond between carbon atom. So according to Markovnikov rule, negative part move to the or attach to the carbon containing less number of hydrogen atom. Well, here this type of reaction takes place. Plus H2O, or you can write HOH, yesterday I has given this one, in presence of acid, generally H2SO4. In this reaction, H2SO4 acts as a proton donor, that is produces H plus, so protonation of this one takes place. We don't have a detailed mechanism of that reaction, but remember here H2SO4 acts as a proton donor. Now H plus and OH minus, it links to this one, and H plus to this. So we are getting secondary alcohol R, CHOH, CH3. This is from alkenes by hydration in presence of acid. We can also get the alcohol from alkene by using diborane B2H6, or it is BH3 twice. Well, here's RCH double bond CH2, and diborane B2H6, or we can write BH3 twice. Well, again this addition reaction, you are getting finally RCH2, CH2, then it is thrice B. We know this is called alkyl, trialkyl borate, trialkyl borate. After the formation of trialkyl borane, the trialkyl borane is then oxidized by using hydrogen peroxide in presence of alkali like NaOH. The product is RCH2, CH2OH and H3BO2. So remember, here you are getting 1 degree alcohol. Here you are getting secondary, or 2 degree alcohol. This is from alkene. After alkene, the next method we are studied from the carbonyl compound. Carbonyl compound means it may be aldehyde, it may be ketone, it may be carboxylic acid. Yesterday I told we can convert carbonyl compound into alcohol by hydrogenation. Example, we can convert aldehyde into alcohol by hydrogenation in presence of heated nickel, palladium or platinum catalyst. We can convert ketone, it's a carbonyl compound, into secondary alcohol again by hydrogenation in presence of same catalyst. Here you are getting a secondary alcohol from ketone. Well, from the aldehyde it's a 1 degree alcohol, from the ketone it's a 2 degree alcohol. We can also convert carboxylic acid, that's also the carbonyl compound. Yesterday I told it's a RC double bond OH into the alcohol. But here we need a strong or powerful reducing agent like lithium aluminum hydride. Only by using LiAlH4 we can convert carboxylic acid into alcohol. Yesterday we studied this one, but it is not possible to convert carboxylic acid into alcohol by using hydrogen gas and a catalyst nickel or maybe platinum or palladium. This point is very important, you have to remember. Only by using LiAlH4 we can convert carboxylic acid into alcohol. By using nickel, platinum or palladium catalyst and hydrogen, we cannot convert carboxylic acid into alcohol. However, we can convert aldehydes and ketones into the alcohol again by using LiAlH4, or can also use NaBH4, sodium boron hydride. So this is the second method. Now third method is from Grignard reagent. We know the formula for Grignard reagent, RMGX. All three types of alcohols can be prepared by using Grignard reagent. That is 1 degree, that's a primary alcohol, 2 degree, secondary alcohol and 3 degree tertiary alcohol. Yesterday I explained how to get the primary alcohol from the Grignard reagent. Only formaldehyde gives the primary alcohol by using Grignard reagent, and aldehyde other than formaldehyde gives secondary alcohol. To get the tertiary alcohol, you are using ketone. Well, it involves 2 steps. In all this, it involves 2 steps. First one is addition of Grignard reagent, and second it is hydrolysis of addition product in presence of H+. Formaldehyde 1 degree alcohol, aldehyde other than formaldehyde 2 degree alcohol, And third one, I think has not given the expression for third one. It's a ketone, use the 3 degree alcohol. We know general formula for ketone. So ketone gives ketone react with Grignard reagent, react with Grignard reagent to give 3 degree or tertiary alcohol. We know general formula for ketone R C double bond O R dash ketone. Grignard reagent, I am writing RMGX. Grignard reagent RMGX. Well, this is partially negatively charged, polarization takes place. We know magnesium is electropositive, and hence we have a negative charge on R or alkyl group, and this one is electronegative. We know oxygen is electronegative. Pi electron move towards the oxygen. So negative part linked to this carbon and remaining part to this oxygen. No need to show this arrow marks in the examination. Well, you are getting the product, addition product RCOMGX, then it is R and R dash. When it undergo hydrolysis, that is interaction to water in acid medium, the product is R, then it is OH, afterwards R dash, plus Mg, X, and one more is OH. So this is 3 degree alcohol or tertiary alcohol. The example for the ketone, simple example, I am writing acetone or propanol, double bond OCH3. This is propanol or acetone, common name is acetone. Propanol or acetone plus CH3 MgCl. The name of this compound is methyl magnesium chloride, alkyl magnesium halide. We know this is a negative part, this is positive part. Here movement of oxygen takes place. CH3 links this carbon. The product is it's a CH3, then it is CH3, it's a OMgCl and CH3. So this on hydrolysis, in presence of H plus or acid, we are getting this product CH3, COH, CH3, CH3, then we have MgClOH. Product is 3 degree alcohol. I think we know the name of this alcohol. See here, it's a ketone. Example is acetone. IUPAC name is propanol. Totally 3 carbons, so it's a propanol. Plus methyl magnesium chloride. Methyl magnesium, it's a Grignard reagent. Methyl magnesium chloride. Addition reaction takes place. So the addition product then undergo hydrolysis to give the tertiary alcohol or 3 degree alcohol. We know name of this compound. It is tertiary. After tertiary, how many carbon we have totally? 1, 2, 3, 4. That means butyl. Tertiary butyl alcohol, tertiary butyl alcohol, or the IUPAC name of this compound is 1, 2, 3. The IUPAC name is, IUPAC name of this compound is 2-methyl. On the second carbon we have substituent methyl, 2-methyl. Afterwards, total number of carbon atom in the long chain are 3. So it is propan. 2 on the second carbon we have OH. So these are the different methods you are using to prepare alcohol. One is from alkene, we have 2 methods, remember these 2 methods. Second one is from carbonyl compounds, we have 3 methods. So from carbonyl compound, it's from aldehydes, you are getting primary alcohol. From ketone, you are getting secondary alcohol. And from aldehyde, formaldehyde, okay, you are getting 2 types of alcohol. From aldehyde, you are getting primary alcohol. From ketone, you are getting secondary alcohol. And from carboxylic acid, you may get the primary or secondary alcohol. It depends on the structure of carboxylic acid. Well, after this, it is about the study of properties of alcohols. We know the formula for alcohol. General formula is ROH. So the structure is similar to that of water, like H2O it is ROH. We know the formula for water H2O or HOH. And bond angle in case of water is 104.5 degree. Well, in alcohol, it's ROH. Structure is similar to that of the water. Bond angle is slightly greater than 104.5 degree. It's greater. Always it is greater than 104.5 degree. Question arises, why it is greater than 104.5 degree? This is because we know this group is bulky group compared to hydrogen. Compare to hydrogen, alkyl group is bulkier. It's bulkier than compared to hydrogen. Alkyl group is bulkier. Therefore, bond angle of alcohol is greater than water. Structure similar. We have bent shape. We know shape of water is bent, and oxygen is sp2 hybridized. Sorry, sp3 hybridized. This is also sp3 hybridized. Both have bent shape or V shape. Here there is a greater repulsion between the bulky R or alkyl group and hydrogen. This is bulkier, so repulsion is greater. Due to greater repulsion, there is a slight increase in the bond angle, so it is greater than 104.5 degree. It is for water, this is for alcohol. So for sp3, as we know again, for sp3 hybridization bond angle is 109 degree 28 minute. Due to 2 lone pair of electrons, this you are studied in the first year, there is a greater repulsion and the bond comes closer because there is a greater repulsion between the lone pair and lone pair that you are studied in first year. Due to greater repulsion, the bond comes closer, so bond angle decreases to 104.5 degree instead of it is 109.5 degree. And here slight increase, it is due to the repulsion between the larger alkyl group and hydrogen. So always you have to remember the bond angle of alcohol is greater than that of the water. Well, we have a bent shape, it's R, O, H like this. In physical properties, we have to discuss about solubility of alcohols and also about boiling point. Alcohols are soluble in water. Why it is soluble? It's due to hydrogen bonding with water. And the solubility of alcohol in water decrease with increase in the R group or with increase in the number of carbon atom in alkyl or alkyl group. It is due to the hydrophobic nature of that alkyl or aryl group. As the number of carbon atom increases, then the hydrophobic character increases and solubility decreases. So higher members of alcohols are insoluble in water, lower members are soluble due to hydrogen bonding with water. This is very important point. Lower members are soluble due to hydrogen bonding with water, and higher members insoluble due to hydrophobic nature of that alkyl group. As the alkyl group increases, hydrophobic character increases and it remains insoluble in the water. Afterwards, about boiling point. We know boiling point depends on the interaction between the molecules. Well, in case of alcohols, boiling point of alcohol increases with increase in the molecular mass or with increase in the number of carbon atoms. For example, boiling point of ethyl alcohol is greater than that of the methyl alcohol or methanol. This is because of greater interaction between the ethyl alcohol molecules. We have 2 carbon atoms compared to in case of the methyl alcohol, 1 carbon. 2 carbon interaction, van der Waals interaction become greater. Due to van der Waals force, greater van der Waals force, boiling point increases. Second point, the boiling point decreases with increase in the branching. For example, in case of butyl alcohol, we have N-butyl alcohol or 1 degree butyl alcohol. It's a long chain CH3, CH2, 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 OH. Long chain. Then isobutyl alcohol CH3 twice CH, CH2, OH. Then tertiary butyl alcohol, we have 3 CH3 group attached to 1 carbon and carbon is attached to OH. That means the surface area become less. As the branching increases, the surface area decreases and interaction between the molecules decreases. When interaction decreases, we know the boiling point also decreases. So branching, increase in branching decreases the boiling point of alcohol. Well, it's about the physical properties. Physical properties. Some physical properties. Number 1, it is solubility. Solubility. Alcohols are soluble in water. Alcohols are soluble in water due to hydrogen bonding. Due to hydrogen bonding with water. Due to hydrogen bonding with water. Then solubility decreases. Solubility decreases with increase in carbon number. Increase in carbon number. Because of hydrophobic nature. Second one is boiling point. As we know, boiling point of alcohol increases with increase in molecular mass or with increase in the carbon atoms in the molecule. BPT increases with increasing molecular mass. It is nothing but carbon number due to increase in van der Waals interaction. So this is first point. Second point, boiling point decreases with increase in BPT, decreases with increase in branching, because of decrease in surface area, decreases van der Waals interaction. Example for butyl alcohol. Boiling point order is CH3CH2 CH2CH2OH is greater than CH3 CH3 CH2OH. It is greater than CH3 CCH3 CH3OH. Well, here branching is greater. This carbon is surrounded by 3 CH3. Branching is greater compared to this one. Here we have one branching, here we have two branches, and here there is no branch. It's a long chain. So we have a large surface area in this case compared to this one, So boiling point orders are this type. And afterwards, next point is boiling point of alcohols are greater than ethers and hydrocarbons because of intermolecular hydrogen bonding in the alcohols. BPT of alcohols are greater than ether and hydrocarbon of comparable molecular mass due to intermolecular hydrogen bonding in intermolecular hydrogen bonding intermolecular hydrogen bonding in alcohol. There is a lack of intermolecular hydrogen bonding in ether and hydrocarbons. We know intermolecular hydrogen bonding is possible when the hydrogen atom is attached to the most electronegative element like fluorine and oxygen. We know the formula for alcohol ROH. So this bond is polar. OH bond is polar. It carries partial negative charge. This one carries positive charge. So it can bond again because of that partial positive character. It can bond again to the oxygen. It can link to the oxygen atom. That means here we have a weak bond between the hydrogen and oxygen. This is called hydrogen bonding. So association of alcohol molecule takes place. So this is called intermolecular hydrogen bonding. That type of hydrogen bonding is not observed in ether. No hydrogen bonding in ether because here no hydrogen bond. No hydrogen bond. This is because there is no hydrogen atom attached to the oxygen. Similarly, no hydrogen bonding in hydrocarbons. For example, R dash, no hydrogen bonding. There is no oxygen or electronegative atom. No hydrogen bonding here, no hydrogen bonding here. Here we have intermolecular hydrogen bonding. This point is important because of intermolecular hydrogen bonding. Boiling point is greater compared to that of the hydrocarbons and ethers. It is of the order. This alcohol greater than ether ROH, greater than ether RO R dash. It is greater than hydrocarbon RR. So comparable molecular mass. Example is CH3, CH2OH. Boiling point is greater compared to CH3, OCH3. It is greater compared to CH3, CH2.